So hello everyone, how are you? And welcome to a third video on Arduino. So it's a good series going on. And if you've not watched the previous videos, please go watch them now. They'll be right there. And then click it and watch it so that you have a better understanding of these videos. And now today what are we going to do? We're going to finally start to code. So yay! And we're going to do two programs today. And both the programs include the onboard LED L, which is present on the board. You can see it is here. I've already explained it in video one how it is just as an onboard LED. So it might be red on some boards, it might be orange in some boards, but we're going to program it. So the first program will be just to turn this LED on, but the second program will be to make this LED blink. So we are actually going to make this LED here blink. That's going to be very cool. I'm going to show you how to upload, do all that. So should we get started? Let's go. So now let's start to code. Okay, so now you can see we have some terms like void setup and void loop here. It's easy. Okay, I'll just be explaining it to you now. So now what is void setup? Void setup is basically a place where you can define if your pin is an input or an output. Now what is an input or an output? Now it's very easy. So now let's see what's an output first. Now there is an LED and a buzzer. Now what does an LED do? It gives off heat and light, right? So if some and a buzzer gives off sound. So if something gives off, like an LED gives off heat and light, a buzzer gives off sound, it gives off something. That is known as an output. Now input is the exact opposite of an output. Now if we take a distance sensor here, and there is, you can say, there is a brick. So what does it do? Now it measures the distance between itself and the brick. So now this is two factors. It takes an input and an output. Now the output is that it's giving off waves of light, I mean waves of sound. Like it gives off waves of sound to detect how far the object is. The input is basically the input is basically taking the waves back in to measure how much distance it is between itself and the brick. So what is the output of the distance sensor? The output of the distance sensor is emitting waves. What is the input of the distance sensor? It's taking back in the waves, the reflected or the bounced off waves from the object to determine how much distance is between itself and the brick. Okay, so that is an input and an output. Void loop is basically the place where you can write a real code. It repeats over and over again. So what do you mean by repeating over and over again? Let's take an example. Now example, there are 3 lines of code in the void loop. Now what will the void loop do? It will execute the first line of code, then move on to the second line of code, then execute the third line of code, and from the third line of code it'll move back to the first line of code, execute the first line of code again, then execute the second line of code again, and then execute the third line of code again, then move back to the first line of code, and then execute the first line. It'll just keep repeating over and over again. Okay, so that is repeating. The void setup and the void loop are defined as functions. Now what are functions? Functions are nothing but a line of code which does a particular action. Now what do you mean? How do we identify a function? Now basically, if you can see, this line of code here is a function. It does something. I'll be explaining what it does in a few moments, like in a few minutes, but not now. So the function name is pin mode. Now how do you identify this as function? There's an open bracket here and there's a closed bracket here. Okay, there's a word written before the bracket and there is something written inside the bracket. This is how we identify a function. So inside this bracket, inside these two brackets, there might be something written inside, there might not be something written inside as well. Okay, so like here, this is also a function. You can see there's a word written before the bracket, and you can see nothing's written inside the bracket. So we call this function as a loop. We call this function as a pin mode. Pin mode because the word which is written before the bracket is considered as the function name. So here the function name is pin mode, and then here the function name is loop, and the function name here as well is void setup. Now even this digital write is a function. How do we identify a function? The word, I mean, something is written inside the bracket. There might be nothing written inside the bracket as well. There is an open, I mean, there's a closed bracket, there's an open bracket, there's a word written before these brackets, and the word written before these brackets is the function name. So this line of code is a function, and the function name is digital write. That is how you identify a function. Also, the void loop and the void setup are written inside curly brackets. Now, as you can see, the void setup here, there's an open curly bracket and there's a closed curly bracket. So whatever you write inside these two curly brackets, you can see the function pin mode is written, right? So whatever is written inside these two brackets belongs to the void setup. Just like that, there's an open curly bracket here and a closed curly bracket here for the void loop. So what is written inside this belongs to the void loop. Okay. So now one more thing is that here, if we actually take this digital write and I cut it and I actually put it in void setup, then what happens here is that this digital write belongs to the void setup now. Even the pin mode belongs to the void setup. But obviously, I want to write a digital write inside the void loop. So again, I'll just cut this using Control X and then I'll use Control V to put it back here. I just wanted you to explain that whatever is written inside the void setup belongs to the void setup. I mean, inside these curly brackets belongs to the void setup. Now let's move on and see what actually the functions do. What does the function pin mode do? Now pin mode just determines if your pin is an input or an output. You can see the syntax is on the screen. Now input or an output. Now you can see that we write pin mode and inside the bracket we write the pin number and then input or an output. Now here instead of pin number we have written LED built in. Now why? Because we are not actually connecting any external LED to pin on the board. We are just using the onboard LED. So instead of pin number, we have a special keyword known as LED built-in. LED underscore built-in in all capitals. This is basically to describe the onboard LED. We write it instead of the pin number if we want to describe the onboard LED. Now we already know that the onboard LED is an LED. Now we know LEDs are output. So instead of input, we write output here because it's an output. But if the device was an input, then we write input here, but it's an output. So yeah, pin mode, pin number, we don't have any pin number, so LED built in, and then input or an output, it's an output. LED is an output. Now we told the board that the onboard LED is an output. But now we should tell the board that the onboard LED should be on. So we have a function known as digital write to do the work for us. Now you can see the syntax is on the screen. Digital write pin number high or low. Now instead of pin number we write LED built in again. And here what is high or low? High basically means on and low basically means off. Okay, so here we tell that the LED should be on, so we write high. But if we wanted the LED to be off, then we would write low instead of high. But we want it to be on, so we write high. So we have just told the board that the onboard LED is an output, turn it on. So we have written a successful code. So for this first, we should see if we have written the code correctly. So you can pause the video, write the code, and we have to verify. Now there's a special, you can see up here, if I click this here, there's this verify button. So this verify button basically verifies if your code is correct and checks for any errors. So now let's click that button. So let's verify, and you can see here it says compiling sketch. It basically compiles your sketch. You can see there's a bar here which tells the progress, and you can see it says done compiling, which means all our syntaxes are correct. Okay, now here you have to pay attention to important thing which will be useful in the future, not now. Sketch uses 724 bytes, 2% of program storage space. Maximum is 32,256 bytes. Now what does that mean? Now Arduino is hardware, right? So there's only a certain amount of storage space that it can take. Now we have written a code for 724 bytes. Okay, but the maximum amount of code you can write in terms of bytes is 32,256 bytes, which is actually a little more than 32 KB. And 32 KB is actually lesser than an MB. Okay, so it's not that much space. We can write a 1,000 line program, maybe a 2,000 line program, but you can't write a million or a billion line program. You can see we have already conquered 2% of the program storage space. So we have used 2%. So if we write this code 50 more times, right, then we'll reach 100%, and we can't write any more code than that because the maximum is 32,256 bytes. But we should not worry about this because we're doing basic programs. But for high-end projects, this might be an issue. So we won't we won't deal with it now. So we won't worry about it. Okay, now we have done compiling. So now we have to upload the code to the Arduino. There's a special button here called upload. And yeah, this button is for uploading. There's also what is that? Um, there's also a keyboard shortcut for this called Control U. But now I'm just going to be pressing this upload button. Now, before pressing this upload button, I just want you to know that when uploading the sketch here, we can notice it'll say done uploading and all those stuff. But on the Arduino, some lights will flash, and I'll even show from the Arduino point of view what happens when you upload a sketch. So first, let's see from the IDE point of view what happens when you upload a sketch. So before uploading, you should check a few things. For example, you should check if in our tools, we have already explained this in the second video, that the board should be Arduino Uno because we're using Arduino Uno, and your COM. Now, COM, I have not connected the board yet. So let me just connect the board, and you can see a sound will come here. So if I connect the board, you can see a sound has come. That is the sound of the board connecting. And now if I go to tools and if I go to port, you can see it's already selected COM4 Arduino Uno. But sometimes the Arduino Uno, what is that, name will not come. Only the COM number will come. It's fine. But for me, the Arduino Uno is coming COM4. So I'll select COM4. Now if I upload the sketch, you can see it says uploading, and yeah, it's done. See, before uploading, the Arduino IDE actually again compiles it, verifies it, then uploads. But it's always better to just verify your code. Okay. So now we have to see from the Arduino point of view what happens if we upload a code. Okay, now let's get back to our code. You can see we have not changed much here. You can see still pin mode is there. Here LED built-in high, but we have added some new stuff here. Like we have added a new function known as delay. You can see why it is a function, because there's a bracket, there's a word written before the bracket, and there's something inside the bracket here. So this function is known as delay. So I'll be explaining what that is, but before that, we should know here there is this, digital write LED built-in low. I just explained a few minutes back what is low, so hope you remember. Low is basically off, high is on. Again, we had delay 1,000. Now, what is delay? Delay is basically to stop or halt the microcontroller for a few seconds. That means in that particular amount of time, the processor does nothing. It is idle. It leaves everything, like it doesn't do anything. So here we are saying, and you can see the syntax is on the screen saying that delay takes the time in seconds. So if I mean milliseconds. So if I take delay here, delay 1,000, that means 1 second. Why? Because we want to turn on the LED for 1 second, turn off the LED for 1 second. So we say digital write LED built-in high, okay, turn the LED on, and then stop the microcontroller, stop everything. So the LED will be on for 1 second, and then digital write LED built-in low, the LED will become off after 1 second, and then again 1 more second wait. That means the microcontroller or the processor stops everything again and then waits for 1 more second. So this is 1 second, this is 1 second. So it'll be on for 1 second, it'll be off for 1 second. As you know, the while loop repeats as I told. So it'll come back to the first statement and again execute everything. So we'll keep repeating. If you want, we can actually change this to whatever. Like if I keep 500, that means it will only stop for half a second. That means like, half a second is 500 milliseconds. So get it? What is this notification I'm getting? Oh, okay, fine. Someone is saying that. Oh, okay, you're right. You're right. I'm sorry. One of the people told me that I did an error in this program. I can't seem to find it out though. Where is this thing? We have done everything properly, right? We have written pin mode. We have declared everything properly. Then what is the error? Okay, let's find out the error by verifying the code then. No, these people are just, I don't know, they're pranking me or something. Let's see. Oh, expected. Oh, okay. In this line, but I put a semicolon. What is this thing? Okay. See, now we know that is one thing. For example, an error is in line 3, it will point out in line 4 that there is an error. So, yeah, that is one thing this is silly actually. I forgot a semicolon. Okay, whatever. Now we can actually upload this code, I think, now. Hope Okay, now let's just upload the code by pressing upload. You can see here something prompts up saying that you should save the sketch. I have not saved it. You can see it's still in the default name September 11. I've not saved it, but I'll just click cancel because I don't want to save it. So now it's uploading and it's done. Now you can see here right there, you can see that the LED is blinking and that means the uploaded program is successful. So yay! Now we can party. So let's party. The party, party, party. So for those of you who don't know, we have an official Discord server. Yes, you can see we have general and we have announcements. So the link of the Discord server will be in the description. Don't forget to check it out. So we will be posting all the new announcements. We have even posted some things here. So all the new videos which are coming before that, we will be posting on the Discord server. Yes, let's go. So I'm just browsing on the official Discord. I mean, Discord. Oh, I just talked about Discord, not Discord, obviously. This is the official Arduino site. I'll be explaining it in future videos about how you can use it as even a forum, which I'll be telling how. Don't just go there and use it. Listen to me first, okay? I'll upload a video on that, like in 4 or 5 videos. I'll do it. So yeah, on this, I'll be ending the video. Hope you enjoyed and learned something today. Bye bye.